This is going to be a fun tournament after all. 8 teams, 4 games, 4 winners. Check this out. 3 experts have already made their picks. I have but one question for you. Just one question, so listen carefully. Who plays who? Stay tuned to your TV set and you will not be disappointed. Hello, I'm Shankar and you're watching Math 11, where math is nothing but a playground of numbers and ideas. So, what have we got in store for you today? Let's take a look. We're going to learn about Venn diagrams, the 2 operations of union and intersection of 2 sets, representing the operations of union and intersection with the help of Venn diagrams. And in the end, we see how this topic should be tackled in the exam decoded section. Close your eyes for a few seconds and try to remember your day so far. Almost all of you would have recalled your day in images rather than in words. That's because we are more likely to remember a visual clue than an audio clue, right? Figures form the base of mathematics. Figures bring mathematical problems to life and help us to solve them. So how do we represent sets in figures? The approach is so intuitive, you would have tried this one out anyways. Figures used to represent sets are known as Venn diagrams. Venn diagrams are in the form of simple closed figures such as ovals and circles. A rectangle is used to represent a universal set. The set U is represented by the interior of a rectangle. Generally, other sets are represented by circles within a rectangle. However, triangles can also be used. Let me simplify this for you. Take a look at this example. Here, U, that is the universal set, is equal to 2, 4, 6, 8 and 10. The set A is equal to 4, 6 and 10 and B is equal to 6 and 8. A and B are subsets of U, the universal set. Now when we define a concept in mathematics, we tend to ask what can be done with it. Our attention then turns to operations like subtraction, addition, multiplication, division, and so on. Can we add 2 things, for example? In the case of numbers, we get back numbers from such operations. How about with sets? Now let's see 2 basic operations of union and intersection of 2 sets. So consider the 2 sets A and B. Then the union of sets A and B is defined as the set of all elements that are either in A or in B or in both. Remember, common elements are written only once, no repetitions. The union of sets is denoted by the symbol U with the keyword OR. So how do we define the intersection of sets A and B? Easy, it's the set of all elements common to both A and B and is indicated by an inverted U. Here the operating word is AND. Take a look at this next example. Suppose a set of girls A and a set of boys B of a class are given. We can get the set of students of that class. The new set obtained is known as the union of sets A and B. It's represented as A union B is equal to the set of students. And its diagrammatic representation would look like this. A real-life example would be that of an orchestra. You can look at this as the union of a set of violinists, a set of flutists, a set of horn players, and so on. And of course, don't forget the conductor. Now let's look at an example of the intersection of 2 sets. Suppose L is the set of animals that primarily live on land, and W be those that stay in water. Then how about L intersection W? Hey, these are the amphibians, right? Frogs, and you also have crocodiles and such. Alright, now, when your concepts are clear, it's time you handle a question. Let A is equal to 2, 4, 6, 8 and B is equal to 1, 2, 3, 4. Find A union B and A intersection B. Easy one, right? So while you solve it, I'll take a short break. See you with the answer. You're back with the answer, I hope. Hi, this is Shankar, your personal guide to the world of mathematics. And you're on Math 11, where your problems with math turn into nothing more than a distant memory. Before the break, I left you with a question, and I started working on a Venn diagram, as you see. Let A is equal to 2, 4, 6, 8, and B is equal to 1, 2, 3, 4. Find their union and their intersection. I also told you that this question was a simple one. You better get it right. Anyway, the answer is A union B is a set of elements which are in A or in B, or both of course. So, A union B is equal to 1, 2, 3, 4, 6, 8. A intersection B is the set of elements, remember, that are common to both the sets. So, A intersection B is equal to 2, 4. Remember the tournament with the 8 teams that I discussed at the beginning? Well, it must have got you hooked, right? You must be waiting for the answer, so here's how you crack it. There are 3 experts whose picks can be placed in a Venn diagram with 3 circles. Take care of your overlaps. Now you may be wondering what happened to the 8th team. No, there's no mistake. They just don't figure on anybody's picks. Call them Team X. Now, I'll drop a strong hint. No team in a circle plays against another one in the same circle. Just apply this reasoning and you will arrive at the right answer. For a better understanding, it always helps if you can come up with different situations to apply the concepts. Also, this is the place where I am open to questions and doubts. In fact, let's take a question right away, shall we?
Hi sir, my name is also Shankar. I just wanted to ask you a question today. What is the union and intersection of 2 sets A and B if A is a subset of B?
Terrific question, Shankar. That's what I'm here for, to make sure that I answer your questions and make sure that those marks are yours. Let me answer this question with an example. Consider a bunch of roses and another of flowers. Now, roses are flowers. Call the first set A and the second set B. Now the union of these 2 sets, you're right, is a bouquet. And their intersection is the set of roses. So we conclude that when A is a subset of B, then A union B is equal to B and A intersection B is equal to A. You guys, you're always posing questions to me. For a change, let me pose one to you. Do we always have to have intersection of sets? That is it necessary to have some elements in the intersection of the 2 sets? Let me see if you knew the answer. The intersection of 2 sets may simply be an empty set. Have a look at these cases of intersections of sets. They're a little different. Suppose the set A is a set of odd numbers and the set B is a set of even numbers. So there are no common elements to set A and B. Therefore, A intersection B is an empty set. In fact, sets which do not have any common elements are specially termed as disjoint sets. Humans and plants, a set of boys and a set of girls are all examples of disjoint sets. Sets satisfy several properties that are analogous to those satisfied by numbers. Here unions are analogous to plus, which is addition, and intersections are analogous to into, which is multiplication. Check out some laws that are analogous to those satisfied by addition and multiplications of numbers. 1. Associative laws. 2. Commutative laws. 3. Identity laws. 4. Distributive laws. All these laws can be verified using the Venn diagrams. But that's only verification, not proof. We've studied a lot about Venn diagrams, but now let's take an insight into the life of John Venn. We have talked about Venn diagrams in the episode. They are attributed to John Venn, who was a Cambridge mathematician who wrote extensively about logic and chance. Venn had other skills and interests too, including a rare skill in building machines. He used his skill to build a machine for bowling cricket balls, which was so good that when the Australian cricket team visited Cambridge in 1909, Venn's machine clean bowled one of its top stars 4 times. His son gives this description. Of spare build, he was throughout his life a fine walker and a mountain climber, a keen botanist and an excellent talker and a linguist. A healthy number of intersections in a man, you would agree. Okay, let's leave history behind us and look at the representation of the set A intersection B, union C. This set will have the common elements of A and B together with all the elements of C. Here is how the sets A union B intersection C and A intersection B intersection C will look. Let's take another example. Suppose A is equal to 1, 2, 3, 4, B is equal to 3, 4, 6, 7, and C is equal to 1, 6, 8, 9. Then find A union B union C and A intersection B intersection C. This one's pretty short. A union B is equal to 1, 2, 3, 4, 6, 7, and A union B union C is equal to 1, 2, 3, 4, 6, 7, 8, 9. B intersection C is equal to 6. Again we have A is equal to 1, 2, 3, 4. Therefore, A intersection B intersection C is equal to 5, the null set. So here is a case where none of A intersection B, A intersection C and B intersection C are empty, but the overlap A intersection B intersection C is empty. It's time for me to take another quick break. And right after that is the exam decoded. So move at your own risk. See you in a bit. Welcome back to Math 11, where you think logically to score magically. Hi, I'm Shankar, and I'm glad to have you with me here. Let's have a quick recap, and then we'll move on to the exam decoded section. The union of two sets A and B is the set of all the elements that are either in A, or in B, or in both. The intersection of two sets A and B is the set of all elements common to both the sets. The sets and the operations on sets can be represented diagrammatically using Venn diagram. Sets which do not have any common elements are called disjoint sets, Learn, understand and solve. I'm going to put you to the test because marks are not that easy to come by. A rapid fire round where you give yourself 1 mark for every right answer. So let's begin. Question 1. If A is equal to 349, B is equal to 26, then A intersection B is given by 1, 2, 3, 4, 6, 9, 2, 2, 4, 3, 3, 4, 9, 4, empty set 5. The answer is option 4. Question 2. If A is a subset of B, then A intersection B is given by 1, A, 2, B, 3, 5, 4, not defined. The answer is 1. Question 3. Union and intersection of sets satisfy the commutative law. True or false? Answer, true. Question 4. If A is equal to the set of elements X such that X is a prime number and B is the set of even natural numbers, then A intersection B is, your options are 1. The singleton set 2, 2. Prime numbers, 3. Natural numbers, 4. The empty set. The answer is option 1. Here's question 5. If A is equal to 2, 5, 7, 9, 11, B is equal to 1, 5, 9, 13, 14, then A union B is 1, 1, 2, 5, 7, 9, 11, 13, 14, 2, 1, 5, 9, 13, 14, 3, 2, 5, 7, 9, 11, 4, 2, 11, 13, 14. The answer is 1. Let's see how you fared. If you got 5 points, you're the high flyer of this week. Got 3 to 4, it's not bad at all. You're an achiever. If you got anything less than 3, you're a learner. I would advise you to work a little harder. What's a better place to go than to topperlearning.com? In fact, all of you high flyers and achievers should also browse through the study material and take the online tests. Sets is a part of the unit Sets and Functions, which is worth 29 marks in your final exam. And that's quite a lot of marks. A 1 mark or a 4 mark or a part of a 4 mark question can be asked from this topic. This topic tests you on your conceptual and representational skills. Concepts should be clear, and believe it or not, how you present an answer can make all the difference. Questions could be finding the union or intersection of sets, representing the sets in the form of Venn diagrams, etc. Let's now look at an ideal way of answering a question based on conceptual ability. Don't forget to make a note of this stepwise marking. Here's your question. Let A and B be sets. If A intersection X is equal to B intersection X and A union X is equal to B union X for some set X, show that A is equal to B. For this, let A be an element in A. We will show that A will also lie in B. If A is in A, then A must belong to A union X, which is equal to B union X. Then A belongs to B union X. So either A belongs to B or A belongs to X. If A belongs to B, then we are done. We have shown that the set A is a subset of the set B. If A belongs to X, then A is in the intersection A intersection X, which is the same as B intersection X. This implies A belongs to B by intersection. This also implies the set A is a subset of the set B. A symmetric argument shows that B is a subset of A. This means that A is equal to B. I don't want to leave any stone unturned, so I've called in an important guest to give you some tips that you won't get anywhere else.
With regards to this topic, I would like to give you a few pointers. Students should not get confused between the operations of union and intersection. While finding the union of two sets, elements which belong to the first set or the second set or both the sets are considered. But while finding the intersection of sets, elements which are common to both the sets are considered. Remember, while drawing the Venn diagram for union of two sets, we shade both the sets using the same pattern. But while drawing the Venn diagram for intersection of two sets, we shade both the sets using different patterns. That's all from me today. All the best.
Before I leave, I'm going to leave you with a few pointers of my own. For union of sets, the keyword is OR. It's analogous with the addition of numbers. For the intersection of sets, the keyword is AND. It's analogous with multiplication. Use correct symbols to represent Venn diagrams. Set theory forms the foundation for logic and arguments in code. The quintessential Renaissance man, Leonardo da Vinci, once said, "Anyone who conducts an argument by appealing to authority is not using his intelligence, is just using his memory." On that note, ciao.